the important points which you might be currently doing, right? So first you need to think of an area you are interested in, right? And make sure you start reading the research papers, articles, as much as possible from the domain that you are interested in, because finalizing a topic might not be just 1 or 2 days work, right? It may take sometimes weeks or months, because there can be certain topics that you are interested in, but you may not be able to find a really good topic because it's 100% heavily researched. It was there in maybe 30 to 40 years, right? And there are no any novel areas that you can contribute, but these types of areas are very low, right? uh, Even the problem is old, right? You can still come up with new solutions with the latest development and trends, right? So find an area you are interested in, then start reading the papers. So when you are reading the papers, always focus on quality, credible research articles as much as possible, rather than just going through uh, websites or maybe Wikipedia or kind of a less credible uh, repositories. Please focus on research engines or database engines which index the research papers, like we have Google Scholar, IEEE Explorer, Science Direct, Springer, and many more, ACM, and even Web of Science. And there are many research databases which stores the very high quality research papers. So try to read them as much as possible, right? And When you categorize the area, so that is the next important point, right? Because your problem might be very broad in some cases, right? In some cases it might be very narrow, so you have to identify what area you are focusing on exactly, right? So you can make sure whatever the papers you are reading is properly stored. I'm sure currently you are using the different reference managers such as Mendeley or Zotero to keep track of the research papers you are reading and properly organize them. So please use a referencing tool from day one. Otherwise, it's very difficult for you to keep track of the type of papers and the categories those papers belongs to, right? So it's very important to properly categorize your reading materials, the areas you are working on, right? So now when it comes to understanding the problem, now when you say identify a research area, it's very broad, right? So you may end up with a very broad area, like, okay, I'm going to do something related to education, right? Or maybe health, or maybe pure software engineering problem, right? So the area might be very broad, right? So you can think of top down or bottom up approach to understand how the computing solutions can be integrated with your problem, right? Because usually in research we have single disciplinary research and multidisciplinary research, right? Single disciplinary means your problem and solution both are from the same discipline, right? So for an example, say you are doing research to understand how the load balancing can be performed in an operating system, right? So, or maybe the most optimal load balancing algorithm, something. So this problem comes from the software engineering domain itself, and you have to develop algorithm, which is again from the SC. So it's a single disciplinary research. But I'm sure most of you are focusing on multidisciplinary, which means your problem generates from a different domain, like education or health or different area, and you are trying to propose a software engineering or computer science based solution, right? So in this example, what you see, it is also multidisciplinary, no? Because the problem comes from the health domain. We are trying to do a lung cancer prediction, and we are proposing a solution from the uh, SCCS domain. We are trying to see whether image processing related solution can be utilized with the lung cancer prediction, right? So this is an applied research problem. It's not a pure research problem, because we propose something based on the SCCS domain, and we also try to build a piece of software to make sure it's working, right? So now we identify the problem from the health domain, and we propose a solution from the computing domain. So you can see we divide our uh, research area into two domains, right? The problem comes from the health domain. So cancer as a health issue, how widespread it as a health issue, what sort of sub cancer types available, and out of these cancer types, what areas mostly researched, and which areas that you think are not yet researched, and you can propose something new, right? Or in this domain, how you are planning to do the prediction, because currently they might do the prediction using the reports, different medical reports, or maybe the history of the patient's medications, right? So there can be different areas. So if your problem is a multidisciplinary research problem, it's very important that you gain a really good idea about the originated domain. We all are not doctors, so we are not nurses, so health practitioners. But if you are selecting something from that domain, make sure you get that domain knowledge sufficient enough for your problem, because your final viva, they will be definitely checking whether you have enough knowledge on the area you are working on. So it is not only SCO, CS in that case, right? So you need to focus on the domain you are working on, right? And then the second part of the domain here is the computing. So that is where our solution originates, right? The problem comes from health domain, solution comes from computing domain. So you have to again dig into deep and try to find out what are the most applicable solutions you can build from the computing domain. So there can be competitive solutions, like I said, right? There can be image processing solutions already developed for this problem, prediction of lung cancer using image processing. If there are already solutions available from image processing, you can have two options. Whether you go through and find out a missing piece, okay, even though there are solutions available in the image processing domain, this area was not properly examined. For an example, let's say uh, the foreground and background removal. So if we get an X-ray report or maybe a CT scan report, to find out the exact area which helps doctors to predict the lung cancer, this area prediction part is blurred, right? The current image processing techniques are not actually focusing on how efficiently and accurately doctors can isolate the area of a CT scan report which can be used to predict lung cancer. Now we identified a exact specific problem inside a larger domain, right? So now we have to find out, okay, in the existing image processing techniques, there are some algorithms which we can do this foreground isolation, right? But we don't have enough evidence to confirm that existing researchers have gone through these foreground isolation algorithms to give a better solution. Now we open up an area which is researched up to a certain extent, but an area which is underexplored. So you can take that part and maybe design a solution on that, right? Or you can go to another part. Yes, there are enough medical image processing based applications developed for lung cancer prediction section, but the amount of machine learning or deep learning research done on this domain is very limited or not applied at all, right? So now you can see from computing domain, we have multiple options, right? We can go with the pure image processing, we can go with pure machine learning, or we can go with hybrid, right? Medical image processing or image, machine learning based image processing. So there are many options available. So you need to do a very uh, thorough set of reading and background exploration to find out what is the most suitable and applicable option for your problem, right? The solution for your problem. So that's why the reading is very important, because if you do a proper reading, it will basically help you to easily write down your literature review chapter, as well as to improve your knowledge on your domain and what exactly you want to plan, design, and implement, right? If you don't have an idea, okay, what sort of methodology or approach I should take to complete my prototype, you will end up with, heavy number of trial and errors, right? Because you're not so sure, you apply one technique and in the middle of the path, you suddenly understand it is not going to work, you revert back, you start another approach. So if you read, if you take more time to read and understand the existing approaches, the limitations of these approaches, how you can improve this to another level, right? So if you can provide a really good understanding, right, then design and development of your prototype won't be that much difficult, right? So don't rush through this phase, understanding your problem, finalizing your solution, and how this solution can be built. What are the approaches, right? So it's very important that when you are proposing a computing solution, don't think of the breadth, right? Think of the depth. So when you think of the breadth, you may end up with many features. Okay, you focus on image processing and at one part, natural language processing another part, right? Then machine learning a small part. So you are not going in depth into a specific area. Rather, you try to come up with a feature-heavy, fully functional system by combining areas from here and there. So that is not usually what we expect in the final year research. You focus on an area and dig into deep, right? If you focus on image processing aspects, you dig into deep and try to understand what are the missing pieces, how the image processing cycle or pipeline is working, what are the phases you can provide your contribution, pre-processing, feature extraction, background removal, right? What exact areas you can improve your contribution, rather than trying to focus on multiple aspects at once and build a solution with many features from different domains. So that is not what we usually expect, but it doesn't mean that you can't build like something like that. So that is where your supervisor's input is needed, because based on the nature of your solution, sometimes you might need to focus on multiple subdomains of computing as well, right? So this is very important in the beginning. You identify the problem, you identify whether your research is single or multidisciplinary. Then if it is multidisciplinary, you understand what are the domains you are working on. Then based on the domain, up to what level of knowledge you need to get to build a proper solution, education, health, any whatever the area, right? And then what is the most suitable approach you are going to use in building your solution or proposing your research methodology, right? Because there can be one problem, right? Let's say the same problem here, prediction of lung cancers, which we have multiple solutions, right? One student can focus on image processing approach, another student can focus on a machine learning approach, another student can focus on hybrid version, right? A medical imaging based image processing and machine learning. So likewise, one problem can have multiple solutions. So the research focus, the area or the point of view you are looking at the problem can be different. So when you are reading the papers, right, that's what is important at this stage. Read as much as possible, because when you are reading the papers, you will end up with some new methods, new approaches. Sometimes you may in the very beginning you may feel lost, right? You don't know what to do, you don't have any idea about how you are going to end up with, so no idea at all. But if you keep reading the papers, right, slowly you will clear out your path, right? So don't worry. That's the nature of usual research. You will initially feel lost. If you don't feel that, you haven't done enough reading, right? So keep reading the papers related to your area. First, take the most recent ones. And if you don't find enough evidence in the recent papers within last 2 to 4 years, you can even expand the duration, maybe 5 to 10 years as well. But keep reading. That will definitely help you to build more novel and more challenging contribution into your domain, right? So yeah, so that's about area categorization and understanding the domains, and then how you can actually dig into deep on a specific domain, right? Yeah, so the ways of seeking research problems. So like I said, the best option is the last one, right? It's not what supervisor wants, or it's not uh, from the list of topics. As long as you have some topic that you are really interested in, you can pick a topic from list where supervisor gives, or maybe a research team gives. But the last option is the most important and most uh, reasonable one, because without interest you can't live with your research topic for one whole year, right? Uh, so like we discussed, when you're finalizing a problem, it is not few days work. It's taking weeks, and sometimes you might need to drop one, two, maybe five, six problems to finally end up with the most applicable optimal solution. So you should keep reading as much as possible, right? So now, when it comes to the scope, you need to think of these two parts, either to narrow down your research problem, either to broaden up your research problem, right? So if your area is very broad, right, you can think of these aspects to narrow down the problem, right? For an example, now the same example we discussed, prediction of lung cancers. Uh, Based on the user symptoms or medical reports, right? So we are not going to build a solution which can predict the lung cancers from any form. We only focus on either medical report based one. Out of the medical reports, you can even focus whether it is X-ray or CT or MRI or specific report type, right? And then you can further narrow it down in a specific report type. Are you focusing on any specific area, right? Which can easily help the medical practitioners to do the prediction, right? And then the component wise, you can think of different types of lung cancers, and you focus on a very specific type of a lung cancer which has not been explored. So that's another way you can narrow down your problem, right? Find a area which, even though the area is very broad, there can be a subdomain, sub area within the main domain where the researchers have not dig into deep, right? So you can find in terms of the components, if you can break it down to smaller pieces, right? And then the places, right? Now this is basically if you are trying to localize uh, certain researchers. Now I'm sure some of you might found out, okay, uh, there are certain researchers done in the global level, right, but not in the Sri Lankan context, right? Especially, let's say we have the stock market predictions and maybe expense predictions, and even the medical related researchers. You can sometimes justify, okay, this was done for a data set in Europe, but for Sri Lankan data set, it has not done, right? So it's a valid way of narrowing down the problem, but there you have to be very careful, right? Because if you don't see any unique features to localize, now let's say the same thing, lung cancer prediction thing, if it is being done for a European data set, right? And if you want to do it for a local data set, do you really see sort of a difference in the pattern or the behaviors, right? In Sri Lankan version or and the European version? Because it's focused on the lungs, right? So if you can justify maybe the uh, lifestyle and different other factors might change the basic symptoms, so the existing methods are not applicable. So for Sri Lankan context, we may need to explore some new set of machine learning techniques. Yes, then this demography or maybe localizing aspect is also working, right? And then the type, right? From which point of view or from the stakeholders' point of view, you can look into the problem, right? Now, a well researched area, for an example, traffic patterns, right? So it was there for so long, but the way we look into the problem can be different, right? We can look into the traffic control system from the driver's point of view, or maybe the traffic point of view, maybe the controller's point of view, or maybe the pedestrian point of view. Likewise, you can look into the problem from different stakeholders' angles and change the solution, right? So likewise, when you want to narrow down a problem, you can think of one of these ways, which helps you to uh, design a solution to a well-researched area, but from a different angle or different point of view, right? So these are some tips for you to think. If your scope is too high, too large, you can try narrowing it down. Then the broadening up, if your problem is only focusing on a very niche audience or a very specific audience, you have to, based on the nature of the research, you have to uh, maybe take your supervisor's advice and see how it can be expanded, right? You can try maybe categorizing it and focusing on multiple categories together, or maybe focusing on multiple stakeholders together, and see whether you can implement more features into your problem, right? So I think most of the students are having this issue because you all are come up with very promising ideas in the beginning, which may be very difficult to address as a final year project research. So you can focus on these aspects. Okay. Yeah. So that is about maybe some tips for you to finalize your ideas if you are currently working on, and if you still need some time to finalize what exactly your problem is and how you want to build up a solution, right? So the next part of this discussion is to uh, document whatever your findings into the very first type of the document you will find in this FYP journey, which is your project proposal, right? So you need to understand that your final uh, mark, or maybe your final success of the FYP depends on the three aspects. One is the quality of your prototype, right? How well you uh, develop your prototype by integrating your research findings and selecting the most appropriate tools, techniques, and provide a good uh, proof of concept in terms of a working piece of a software, right? The technical prototype, and then the quality of your presentation and the viva, right? So no matter how well you build your prototype, if you can't defend in the final viva, and if your presentation is not well presented, then the audience can't understand exactly what you have done. So your work is in vain. So that's the second part, your final presentation and the viva. And then the third one is your documentation, the quality of your submissions, your IPD, CPRS, and the final thesis submission, right? So you have to make sure all these three pillars you focus in the equal way. Don't only focus on building a fully functional, highly technical prototype if you don't document your findings properly into the thesis. No point of coming up with a really good technical part. You will lose some portion. Then even you come up with a really good thesis and a prototype, but if you are missing the defense, right, the required knowledge to defend your work and highlight your contributions in the final presentation, again, both of your documentation and the prototype effort is in vain. So make sure you focus on all three aspects in the equal manner: good prototype, good documentation, and well prepared presentation, followed by a good Q&A defense. Okay, so in this journey, the proposal part is usually the first one. I believe you already received sort of a template which outlines the core topics and subtopics of your problem. So you need to understand that there can be some topics which is not exactly relevant to your area, because now, for an example, like data set feasibility, or if you want to explain certain things about the data set, but if your research is not exactly focusing on data sets, you may not be able to uh, write anything about the data set. So don't try to just keep filling up the areas if there is no relevance, right? So just make sure you first identify what areas that you're actually working on, and then start writing the proposal. So here I'm trying to focus on the general parts of your proposal, regardless of your uh, topic, right? Regardless of the domain you are working with, you need to always fill these areas. So the first part is this background, right? Research problem and the problem statement, right? Now, you have to always remember the reader, this documentation you are presenting to, the reader can be an non-IT person, and the reader can be, even though the reader is IT person, he or she may have no idea at all on the area you are working on, right? So remember, you are writing this proposal law thesis to someone who is completely new to your domain, right? So you need to write your proposal or thesis or whatever from the reader's point of view. If you write it from the reader's point of view, you can understand whether your article is nicely organized or whether you should improve the clarity and uh, modify it, right? But if you write it from the author's point of view, because you already know the problem, you are the author, so you have a really good idea. So just keep adding the information without a proper uh, organization, then no matter how complex, how challenging, how advanced your research is, if the reader can't understand what you have written, your mark will be go down, right? So you can't blame the examiners in that case, right? You might finally say, okay, I have done a really good work, my prototype is really good, and I have written a really good report, but my marks are finally in a very low level, or it's not what I expected, right? So that's why you have to balance everything very clearly, right? So when you write the proposal, make sure you are writing it to non-IT audience or non-expert audience. So write it from a very clear, organized way, right? So when you write the background of the problem, highlight the facts which makes the reader to understand the importance of the problem and provide the anchor to the similar research and identify the general problem and the specific problem. So usually when you write a research problem and the problem statement, you have to focus on these areas, right? So background of the problem. Now this is the first impression, right? When a reader starts reading a proposal, when they are going through the background, they should get an idea whether this is an actual problem or not, right? So don't try to just write your problem statement or the background in 1 or 2 lines. You have to set up the ground before you start playing, right? You provide the facts from different angles, different aspects, and first give a very clear idea why this is going to be a problem, right? Highlight the facts which make the reader to understand the importance. Now, this is one example, right? Now, the same example we were talking about this lung cancer predictions statements. So there has been an increase of cancer patients during last 5 years, and 25% of such patients are suffering from lung cancers. Now we can't just take these values blindly, right? These are from should be from valid references, valid sources, right? So you can't make kind of assumptions or predictions. Now this is one of the main problems we see in final year students, right? When we ask questions, if your answer is I thought it will work, I assume this is going to work, and I took these values because I thought these are the most suitable values, you are reducing whole lot of marks if you give such kind of uh, ambiguous answers, right? Because when you say research should be always backed by two parts. Either it should be from the existing literature, or you make an assumption, what we call as hypothesis, and you do a testing and verify, right? You can't have the things you think. Something you think can be assumption, which can be converted to hypothesis. Then it has to be tested, and finally you have to say whether what you thought is correct or not, right? Without doing that, you can't say it's a research. So whenever you are producing statistics, sort of evidence into your research, supporting evidences, it has to be backed up either by literature, or you do a testing and your test results should be used as a evidence, right? So keep that in mind, because this sort of answers has reduced the quality of your research a lot, and we have seen many students, even they did a good job, their marks were reduced because they don't have a clear backing evidence to confirm their approaches, right? So like we discussed, that's why quality literature review is required. Your approaches, whatever the methods you are using, or whatever the statistics you are providing, everything has to be backed up by valid, credible literature, or you have to convert your assumption into a hypothesis and do a thorough testing, and finally justify whether your approach is correct or not. Okay, so you can see here the problem. It says we first prepare the background. It says there has been increase of cancer patients, and the literature says 25% of these patients are suffering from lung cancers. Now it redirects the interest of the reader, right? Okay, reader will understand, okay, it seems this is a kind of a good problem. The first sentence it says gives a really good punch to your book, to your basic idea. Then you have to provide anchors. Study has shown that 75% of these patients are recorded due to smoking, and maybe we can provide some more evidence to support your problem, right? Maybe it can be from computing or social communities domains, right? Different aspects. You have to provide more and more evidence to support, right? And then general problem. The countries have spent heavy number of GDPs for medications for lung cancer patients, which has negative impact on the health and financial matrices. So in general, you highlight how this has been a problem for most of the countries. At the same time, you can say some of the existing traditional solutions have not worked well to prevent the lung cancer issues in most of the countries. Now you go to the specific problems. There has been a less research evidence on all early prediction of lung cancers using computing related areas, right? Now you can see first we are not going to jump into our computing solution and start saying we are going to build a lung cancer prediction solution using machine learning or image processing, right? First you set up the background, right? You explain some non-technical aspects. Even though it's a technical research, you can still come up with sort of background information which is not fully focused into your solution. First, give some evidence and explain why this is going to be a problem. Don't try to use this domain to explain your solution, right? So that's one of the main mistakes students are doing. You start directly with your solution. We are building an image processing solution. There has been less image processing solutions for this particular problem. So don't start with that, right? So it's a problem statement, not the solution. So give a really good idea in the beginning. What is the nature of the problem? Why you think this is a significant problem? Your significance of the problem has to be very clearly explained, backed up by the literature, right? So I hope that point is clear, right? Research problem and the problem statement, and you can highlight the fact that there are solutions, right? There are certain traditional or maybe computing solutions, but these are not enough, or these solutions are not able to solve the problem 100%. So you have to show the reader that there is a gap you have identified, because the problem you identified was not 100% solved by existing traditional or computing approaches, right? So give that path. Now you reader start seeing a path, and you also start showing a path to the reader. This is the background. There are certain attempts to solve this problem, but according to the current literature, this problem has not been solved yet, right? Now you provide anchor to your next part, right? This problem is not 100% solved. Now the reader knows what you are going to do next, right? So the general to the specific problem, you have to first start with, kind of more broader part of the problem and slowly move into the specific aspect. Now this is another example, as you can see. The topic is, as you can see, distance learning, right? The research problem, lack of students are in the distance classes. Then the purpose is to study why students do not attend distance education classes in a community college, right? And the research specific research problem, does the use of website technologies in the classroom deter students from enrolling in a distance learning class? So we have to slowly start with maybe a broader problem and slowly provide some evidence and end up with a more specific problem, right? So that's the first part. Usually in any sort of a proposal, I think whatever the proposal that is given to you also, yeah, they are starting with the problem background and the problem definition, problem statement. Now all these are like going very close by, but you can just read some of the examples here. The background is basically the broader domain, right? Problem definition is the most specific aspect, and the problem statement is actually uh, the very specific problem you are going to solve. Now, in this case, can we use machine learning or deep learning techniques to build a lung cancer prediction system? So it says it's a statement that means not more than one sentence, right? The exact problem in a nutshell. So your problem background and definition has to be written in detail to build the background for the reader to understand what you are going to solve. Okay, so I believe that's clear to you. Then we do have the research motivation part. I will come back to these questions after going through motivation. Now you have given a background to the problem, right? You have given an idea to the reader. This is the domain I'm working on, and this is the nature of the problem, and the existing solutions are there, but still these solutions are not able to provide the 100% working solution to this problem, or even there are certain solutions, there are limitations with that. For an example, in medical domain, you would say sometimes doctors may not use any mobile applications or any web-based applications. They may have their traditional techniques, which gives a really accurate outcome. But in terms of time, there are certain mission critical systems where the time is a very crucial factor. So if the time, the processing time is so much, uh, uh, even though the accuracy is very high, we need to improve that solution as well. So you need to uh, provide sort of a background very clearly highlighting the problem you want to solve. Then the motivation is not actually based on your literature. Now I emphasize the importance of providing evidence as much as possible from the literature in justifying your problem, right? I ask you not to make assumptions in the beginning. Whatever the points you are providing, it has to be backed by the literature, or it has to be backed by your hypothesis. But motivation can be mostly, it can be sometimes your personal experience. Now we have seen some students writing, if they select a particular health problem, one of the motivations can be one of their family members are suffering from that particular disease, right? Or maybe when they are going through the research papers, they have seen that this has been a huge problem in terms of the social and community aspects, right? Or maybe while you are doing your placement in your workplaces, you have identified certain issues, so you wanted to see whether a computing solution or a better solution can be developed. So motivation is actually something based on your experiences, or something that you uh, heard or seen, right? It is not necessarily based on the literature. You can have a motivation based on something you read, which is on the literature, but it is not always based on the literature. So motivation can be even your personal experience, and you can also say, this is an area which I am interested, or I am passionate a lot, so this is what uh, motivates me to do this particular uh, research problem. So motivation can be independent from the literature, or dependent based on the nature, right? So you don't need to worry about finding valid evidence to confirm your motivation, but definitely the research problem and the statement has to be backed by the literature and valid evidence, right? So you can write the reasons to select this area as the motivation, right? Then you have the aim, research aim. So again, the research aim should be very simple and concise, and you have to be very clear what are the phases you are going to complete within the research cycle, right? So usually the research aim has to be 1 or 2 sentences, right? The aim of this project is to, I will just change it a little bit what is there in your research proposal sample. The aim of this project, because you are doing FYP project, is to research, design, develop, and evaluate. So you are actually covering 4 phases in your FYP journey, right? You start with researching, that's why you are reading, right? That's why I changed the terms a little bit. The aim of this project is to research, design, develop, and evaluate whatever your solution, right? So these are really good measurement units, so milestones for you to track in which phase you are currently in, right? Because you are starting with research, then based on your research findings you design, based on your design you develop, and finally whatever the developed prototype you test and evaluate, and the findings of your evaluation will measure whether your research was a success or a failure, right? Even though this is one or two sentences, you will see this line is very important because it simply combines all the phases you are planning to cover, right? And then how each phase is connected with each other, because you can't design without a research, right? You can't develop without a design. You can't test or evaluate without developing. So this is a connected set of cycles. So you can't skip any of these parts, right? If you are not putting enough effort on each phases properly, then it is not going to be a perfect research, right? That's the biggest issue some of the students were having, because they rush into the design and development without a research. So what happens, right? To end up with a prototype, then we start asking questions. Okay, how